Washington, D.C. I work as the science graphics editor for the Washington Post, but when I'm not in this concrete encrusted part of the city, I'm up here in the neighborhoods of Burleith and Glover Park in D.C., where I volunteer for the National Park Service to remove invasive vegetation from this arm of Rock Creek Park called Whitehaven Park. Also pull weeds from Glover Archbold Park. Now, about 100 years ago, this neighborhood was fruit trees and pasture. But since then, in the park area, it's developed into an early successional forest. The dominant tree here is tulip tree. There used to be pines in here, but about 10 years ago, the last pine tree fell. And now these tulip trees are starting to fall in high winds. And an understory of beech, maple, and oak is standing by to complete the forest succession. Now it's not the same forest as colonial times, when there were mountain lions and wolves that kept the deer population down. You see down here, there are a lot of tree seedlings and plenty of saplings to take the place of the older trees when they fall. But now we have no big predators. The deer have come back from overhunting, and we just have too many deer in our area. And they prefer to eat native plants, which gives invasive plants the edge. So when a big tree falls, a light gap is formed in the forest floor, and these invasive plants have a field day swarming over tree saplings. Now, one of the perpetrators of these big tree blowdowns is this little plant here. On the bottom is the immature form of, in my neighborhood, Irish ivy, and on the top is the mature form. When the ivy starts climbing on a tree, its leaves change shape, it flowers, its fruits, birds eat the fruits, spread the seed, and we have ivy all over the forest floor of this park that I work in. A lot of people call it English ivy, but botanists tell me, and the American Ivy Society tells me, that English ivy has little hairs on them, on the young leaves and on the young stem, called trichomes. The trichomes of English ivy are pictured here. They're erect and bristly. They sort of look like miniature coral. You have to get a little 10-power hand lens to see this on the bottom of the leaf. The Irish ivy, however, has starfish-shaped trichomes. And all the ivy I've checked in my neighborhood is this Irish ivy, Hedera hibernica. Regardless of what species it is, it climbs these trees, develops these thick trunks, and the National Park Service has trained me to cut a bottom window around the trunks of the trees, depriving ivy of its water source. So this is ivy, typical ivy infestation in Whitehaven Park. You'll notice up here how the ivy has been suppressing lateral growth on the tree. And with this much ivy on the tree, it creates a lot of wind resistance, and these trees tend to be more vulnerable to blowdowns during high winds. So here's the cut made with just a pruning saw. A year after I made the cut, here's the same view. Over here you'll see I missed a little spot. Now the ivy does return. It starts climbing up the tree, so I regularly go in and monitor these trees and keep immature ivy from climbing up the trunks. But a lot of my time is spent in these light gaps where these saplings here get swarmed by invasive vines. Now, a lot of times when I take the vines off, I'm faced with an invasive tree. I believe this lump here is a tree of heaven. This one over here might be a white mulberry. But I keep plugging away at it. Now, when I first started doing this work, I had sort of an antagonistic attitude towards the plants. It was kind of a heated exercise for me, and one day I realized that I really didn't want to have that attitude when I was in the woods. I wanted to have a more positive relationship with the plants. So I thought that this might be a better metaphor for my activity. I recognized that this invasive vegetation, which unlike in this picture require no planting, pesticides, herbicides, are presenting us with an abundance of material that nobody seems to want. So I wanted to figure out a way to tap into this material. So maybe this is a little bit better metaphor, but unlike this rainforest shaman, I don't have the deep background knowledge of the nature of these plants to understand what they have to offer. So I rely on a lot of trial and error and my own cultural resources, which is, in this case, Google Scholar. Generally, if I find something I'm curious about it, I can go to this source, which is all peer-reviewed studies to find out the answers to my question. Now, the results of my experimentation I post on my website, alienweeds.com. I've tried a lot of different things with the local exotic vegetation. I've tried a steam distillation process where I extract essential oils and hydrosols from the plants. I've tried basket weaving. This is immature Irish ivy soaked in water. It becomes, the xylem of it becomes very flexible. Of course, I've steamed the vines and stripped off the outer bark before I get to this point. This is the cooked inner bark of Asiatic bittersweet, which is really tough and kind of fuzzy. So I think it has great potential for weaving. And some people I've convinced to try to spin it have had pretty good luck turning it into a thread. Because I'm an artist, I tend to solve problems artistically. So I've taken a lot of these fibers and tried to make brushes out of them. This is the inner bark of porcelain berry. This is the inner bark, I believe, of multiflora rose. This is the inner bark of Rose of Sharon. And the bamboo here is Japanese arrow bamboo. You can cut one of these drawing pins out in just a matter of minutes. When it becomes dull, you just sharpen it back up again. This is a bas-relief carving in Norway maple with various plant pigments applied. This was cut out by a computer numeric controlled router. I've also tried to make currency out of this stuff to emphasize the inherent value that these invasive plants have. I'm looking for all kinds of different ways of marketing this stuff. This is not a very successful attempt, but 6-pack of Norway maple. But the most successful efforts have been in making woodblock prints where extracted paper fibers, inks, and printing blocks made out of invasive trees come together at this machine, a cast iron hand press, which works really well with my materials. This bed here cranks under the platen. You pull this bar and it applies a whole lot of pressure to whatever is here. And it's usually a sheet of paper on top of an ink block. One of the reasons this is a good tool for me is the papers that I make are pretty highly irregular. Sometimes they have lumps, they cockle a little bit. So if I'm using a rolling press, those cockles can sometimes compound into a wrinkle across the print, which is becomes waste because it's difficult to sell prints that are damaged like that. So because these papers are so labor intensive, I need something that will reliably print for me. Now the images usually begin on a much more complicated machine in the notorious program Photoshop. I take these digital images that I draw and send them to a computer that prints them out using a laser engraver. Now, I used to cut these by hand using the old Japanese mokuhanga techniques, but the woods really aren't appropriate for those techniques. They're either too grainy or too hard, and I was wearing myself out doing that. So I think it's in the spirit of weediness, I got a machine that could crank this stuff out. Now this block here is in-grain Norway maple, which is a fine, wonderful wood to work with. Stradivarius used this wood in his violins, and it's great for block printmaking. The in-grain is a lot tougher than side-grain wood, which with these irregular papers can sometimes get little dings in them, and that's the end of your edition once you get a ding. A ding is a little white flaw in the image printed onto the paper. So here's Norway maple, and this is another wood that I've used in the past. It's a lot coarser. This is white mulberry. This is side grain. It was cut with a CNC router. Here's white mulberry. It's a tree that really loves disturbed, urban, sunny soils. Now, I don't cut trees from the National Park Service area. I rely on nearby private land, or in this case, city parks for my lumber. In this case, the tree had split. It's a tree that's in Guy Mason Park. And it sat there for about a year. You can see these sprouts coming up. So I finally contacted the city park and arranged with them to get a tree service to come in and clean this thing up. It saved me the bole of the tree, which I trucked up to a sawmill, had cut into lumber. It's stick dried for several months. Then I had it kiln dried, and now I've got a studio full of white mulberry. Also do the same with Tree of Heaven and Norway maple. White mulberry is a super abundant tree. You just see it everywhere. It was originally brought over here in the early 1800s to Long Island so that the leaves could be fed to the nascent silk industry. The silk industry was too labor intensive for Americans, and it never took off, but the tree did. Let's see here. The tree did, and now it's almost everywhere in North America. I don't know why it's not in Nevada or Newfoundland or Nunavut. These are ripening white mulberries. I tend to target mulberries that have these white fruits and also have very smooth leaves. White mulberry interbreeds quite extensively with native red mulberry, which has dark fruits and sandpaper leaves. So if I come up onto a tree with sandpapery leaves, I leave it alone. But a lot of these smooth-leaved mulberries have dark mulberry fruits, revealing their red mulberry genes. So I mainly go after the mulberries that are in sunny soils, the habitat that they prefer. And you see them often along fence rows. This one has characteristic rough sandpapery orange bark. And I take these, the sort of moderate sized branches from white mulberry. I steam them, strip them off the sticks, and either make rope with them, or I'll scrape off the epidermis and also the middle layer of hemicellulose to expose the white phloem, the bast of the plant. Now once dried, this bast can store for years, but when I'm ready to make paper with it, I soak it in rainwater overnight and then cook it when I can on a wood stove, outdoor wood stove that's fueled by white mulberry. Now the ash from this wood stove I'll take out and I'll put it in a jug like this with rainwater, filter it through sand, cloth, and pea gravel to produce potassium hydroxide or wood ash lye, which brings the water of the cooking plant fibers up to about a pH 10, which is enough to break down a lot of the plant compounds around the cellulose that I don't want in the paper. So here's white mulberry bast being cooked in a stainless steel pot with potassium hydroxide. Once I bring it up to a boil, I try to save energy, especially if I'm working inside on the gas-fired stove. I'll turn off the gas, wrap it in blankets, and leave it overnight. Now meanwhile, I've taken the sticks that I've dried out from white mulberry, wrapped them up in aluminum foil, and stuck them into the coals of the wood stove. And after the fire's out, I unwrap the aluminum foil, and I've got drawing charcoal. So in the morning, I take off the blankets and do a test. If the fibers pull apart easily, crossways like this, then the bast is ready to process into paper. So I wash it several times and drain the water off and start beating it like dough. This frays the fibers, creating more hydrostatic bonds in the dried paper. So it's really important to beat this stuff rather than put it in a blender, which just cuts the fibers. You want to fray the fibers. When my arms get tired, sometimes I'll shift to these piston stampers. So I put the pot a little lower on a chair and take these 2x4s and just go up and down with my arms to stamp this. It requires a little more water to make pulp this way, but it's a relief. Now here's the pulp suspended in water in a vat. A vat is a concrete mixing vat. I fill with water and suspend this white mulberry fiber in. This is a class I taught at Middle Tennessee State University. They're making paper. In this instance, it's from another invasive mulberry, paper mulberry. They're using an ancient device called a mold and decal here. You plunge these two frames down into the water, draw it up horizontal or parallel to the surface of the water, and the fiber collects on a screen. Then take this this fiber, turn it upside down, and transfer it to a piece of felt. You build a stack of these felts, put them under a 20-ton press to squeeze most of the water out, then take each sheet, put it in an air dryer, or you can transfer it to a piece of glass or a piece of plywood to dry overnight. So here's finished white mulberry paper, the strongest, whitest, really the best grade of paper that I'm making out of the local weeds in my neighborhood. This is a little breakdown of the process. This is for paper mulberry, but white mulberry is very similar. You can tell here that scraping the bast takes the most amount of time. But the yield is pretty good. You don't see a yield like this with most of these weeds. Here's another invasive plant that I harvest in late April. In March and early April, I try to eat as much of this as I can. Garlic mustard was originally brought over here as a pot herb. It tastes quite good when you put it in a frying pan with a little olive oil, stir it up till it's soft like spinach, and eat away. Very flavorful. But when it bolts, it gets bitter and tough, and that's when I harvest it for paper. I try to get it before it sets seed because I don't want to spread this stuff around. I haul it into my alley in big bundles, cut off the roots, strip off the leaves to isolate the stems. Now I once composted the leaves and discovered that my compost was preventing garden seeds from sprouting. And someone told me that the allelopathic compounds in garlic mustard persist even in compost for several years. So all I can do with these leaves is bag them up and send them to the landfill. So I dry out these stems in the sun and put them through a garden shredder, cook them. In this case, I use a little stronger alkali. I'm using sodium carbonate, and sometimes I'll even use sodium hydroxide. But this is a pretty tough fiber. It doesn't lend itself to hand beating at all. So I use a Hollander beater. This is just a machine that circulates the fiber round and round. This is a stainless steel drum with bars on it that scrape the fiber across a stainless steel plate and just hammers it to a pulp. Makes a really bright green pulp, and for a while it makes a bright green paper, but it eventually fades to a sort of tan. This is halfway to tan here, but I'm using this as the background for another analysis of the garlic mustard paper making process. You'll see here that the yield is pretty small, but there's so much of it around me that I think it's worthwhile. It didn't really take that much time to process either. The primary processing time is removing the leaves. So it helps to have help. And this is a photo from an event that took place in 2012. I received a grant from the Visual Arts Center in Rockville, Maryland, to team up with Croydon Creek Nature Center, which was holding a garlic mustard pull. So I used the money to invest in bags, equipment. Also bought them some pruners for future projects. And the volunteers helped me strip leaves off the stems. And I used the leaves to make a paper for a limited edition print that I think is still on sale at the Nature Center. This commemorates the event, and also involves a metric here which lets people know how many stems of garlic mustard went into each sheet of paper. The print is on sale at the Nature Center, and all the proceeds go to the Nature Center and are shared with the Stone and Holt Weeks Foundation. I like for the art to refer in some way to the origin of its material source. This is another print that does that. It was made from 3 weeds. I used this block that I showed you before. It's white mulberry. The paper was made from ivy. I pull the immature vines from the forest floor, haul them into my alley, strip off the leaves, jam them down into a pot, steam it, strip the outer bark off. With ivy, the outer bark makes a terrible paper, so I just compost that. But I'm going for the inner xylem, which is kind of a blonde straw-like material, which in the Hollander beater makes a nice paper. Here I am cooking it in sodium hydroxide. This is it in the beater. So you can see it makes a nice kind of cream-colored paper. It's not a strong paper, but it really loves ink. It absorbs ink really well, and it deforms under the pressure of the letterpress, so you get a nice impression on the paper. The inks used for this print were derived from this plant, Multiflora rose. I imagine that all of you are familiar with this because it's just about everywhere. But I always make sure that I'm not harvesting a native rose by checking this characteristic here. At the base of each compound leaf is this little fringe. So I always check to make sure it has that fringe before I cut it. These are the fruits of late summer, early autumn. And I strip the I strip the thorns off, the prickles off of these rose stems, steam them, strip off the bark, clamp the bark together, and cook it so that the fibers are parallel, and I can isolate these fibers for brush making. Really makes a superior brush. Now this is a late season fiber here. This is late summer fiber, which the fiber is wiry, thick, very tough. But in the early spring, if you get the spring shoots, you can get a much finer inner bark fiber, which you see here in this brush on the right. So this is the process of boiling multiflora rose stems. Now, I was doing a workshop once, and I was boiling some of these stems, and I forgot about the pot on the hot plate, and suddenly remembered and saw that the water in the pot had boiled down into a red viscous liquid. I turned off the hot plate, went back to what I was doing, and came back later and found that the water had evaporated from it, leaving a thick reddish gum, which I've now adapted as my primary reddish color. Very sticky, works really well on a printing block. Now the dried multiflora rose stems I also use for ink making. I put those in a homemade soot collector. This is a stainless steel pie pan with a tuna can suspended underneath it, and I'm burning weed scraps to collect the soot. After maybe an hour of burning scraps, I'll scrape off the soot using like a little brass brush, scrape it off onto a ground glass plate, add a little binder to it. This is gum arabic. On the right, you'll see an ink muller, which I use to grind all this stuff together. And it makes a really fine black watercolor, or if I add a little lecithin to it, I'm sorry, not lecithin, but glycerin to it, it prevents it from drying too quickly on the printing block. I've also focused on isolating the pigments that are contained in this black liquor liquid that's sort of a byproduct of the papermaking process. After I've removed the fiber, I'll boil this liquid down and add white vinegar to it so that the alkali solution becomes neutralized. Because when you're making art, you want pH neutral pigments, pH neutral papers, so that's an important aspect of the art making process. So this is what happens. The sodium carbonate combines with acetic acid to create sodium acetate and a lot of foam, a lot of carbon dioxide, and a little water. The sodium acetate sounds scary, but every time you eat vinegar-flavored potato chips, you're eating this compound. Now, I'm not saying that the black liquor inks are edible. There are a lot of shattered plant compounds in there that give the inks the pigment, phenols, ketones, tannins, so I can't vouch for their safety. There's a little library of black liquor inks. They're all brown or rust or kind of green brown, so they're all quite somber colors, and I like to brighten up the color palette a little bit by using ethanol extracts. This is an ethanol extract from the leaves of white mulberry. Here's a white mulberry dark berry extract. Now, berry extracts are highly fugitive, so you have to keep these colors out of the bright light or they'll fade. The black here from soot is color fast. It's never going to fade. And I found that the black liquor inks are also pretty color fast. I'm always trying to expand my Alienweeds color palette. Here's the white mulberry green here. Here's the multiflora rose red. Down here, this orange comes from the roots of this plant, Asiatic bittersweet. If you pulled this plant, which is pretty easy to pull out of the ground if it's a young vine, I'm sure you've noticed that it's pretty bright orange. I wash these roots, take a potato peeler to them to sort of concentrate the bark, put that in an ethanol bath for a week or so, then decant off the ethanol, evaporate the alcohol, and I'm left with a sort of an orange rusty pigment. Now the yellow down here, this bright fluorescent yellow, comes from this plant, which is an invasive in my woods. It's leatherleaf mahonia, often used as a landscaping plant. It blooms in the winter, has bright yellow blooms, and then by June it has these navy blue berries that the birds like to eat and spread around. Berries are also really high in vitamin C and are edible to people, but I try to get to these plants before they get that far. Now this yellow here is literally fluorescent. If you put it under ultraviolet light, it fluoresces, it throws off light. The compound doing this is a medicinal compound, the antimicrobial compound berberine, which is found in golden seal. Now, once a year in late April, I get a purple color. Now this is magnified here, but it shows you the root crown of garlic mustard cut down the middle, cut longitudinally. So I dig out these little purple nuggets full of anthocyanins and put them in a mortar and pestle to get this sort of bluish color here. Now, and I have to use it right away, because if I try to store it, it turns gray on me. But once I get it on paper, it seems relatively stable. If I add just one tiny grain of sodium carbonate to this, it'll shift to cyan, more of a, I don't know, North Carolina blue. If I take a tiny drop of white vinegar and add to it, it shifts pink. So this is a pH indicator. But I only have access to this one time a year, and it's very labor intensive to extract, and it's a relatively weak pigment. Blue pigments are difficult to find in the plant kingdom, but I've managed to find one sort of bluish pigment at the end of my alley from the inner bark of this plant, Amur honeysuckle or bush honeysuckle. I stumbled onto a process by accident which will turn the inner bark into an aqua color, which I scrape off, put through a mortar and pestle, filter it, evaporate it, turn it into a printing ink, and I have sort of a blue pigment here now. So red pigments, yellow pigments, and brown pigments are great, but when you have a little blue, it adds a new dimension to your image. Now the use of the extraction of blue may be a novel use for bush honeysuckle, but I like to think that my work is a form of remembering, a way to build a relationship with these plants that are offering so much abundance. I don't expect everyone to make art with invasive plants, but I do encourage people to use their own imagination and expertise to find new uses for these things that don't seem to want to go away. They seem to want to stick around, so I'm trying to come up with a model that can find a positive use for the plants. I'd be happy to answer any questions.
Thanks, Patterson. That's fascinating work that you do. You're quite a master of your art. One question that was posed is where can these this art be purchased? Is it something that you probably obviously do this in a limited basis? So
well, part of the model that I'm trying to build is an economic model where the plants are actually funding their own removal. So marketing my art is part of the process. People can find the art at different levels of affordability on my website at alienweeds.com.
Okay, great. Not a lot of questions, but quite a few thank yous and compliments for the outstanding work that you're doing. I just think it's remarkable what you've been able to take these plants and do with them. So I know in this case a lot of people like to ask questions offline, so I think that, Patterson, did you put your email up there or contact information? I can't remember if you did.
I don't know how to see that. Can I just type in?
Sure, you can just
chat?
You sure can. Yeah, why don't you do that? And then that way everybody will see that as I just send it off to everyone.
Let's see, I don't see the chat. I can't quite click into the chat.
Well, if you want to, you can go ahead and tell me and I'll put it in there.
Okay, it's PATTCLARK at gmail.com.
PATTCLARK at gmail.com. I'm going to send that out to everyone. There, everybody's got your contact info.
Okay.
Yeah, thank you so much. That was really, really interesting, and I look forward to talking to you more about some of the work that you're doing. And thank you, everyone, for joining us today.
Well, thank you, Steve. I appreciate being asked to do this.
Okay, we'll talk to you soon. Thanks, everyone.
All right. Take care, everybody.